lesson is here, and we are still in trig triangles. Things are getting a little bit trickier. Okay? So let's quickly go over it. I know we've done it in class, but just for the visitors who are joining us in a video. The tools. You know, whenever we try to solve problems, you must have tools in your bag. And the tools we're using are the sine, cosine, and area rules. Okay? And the sine rule is basically the sine divided by the sine opposite, sine of the angle opposite to it. That ratio is equal. So A over sine A equal B over sine B equals C over sine C. Obviously, we sometimes actually want to invert it. So write sine A divided by A equals sine B divided by B and so on. So you can, it depends on the problem. Okay, whatever is easier, whatever is more useful. The cos rule, probably the most complicated one I would think, is start like Pythagoras. The square of the side is equal to B squared plus C squared. Okay? If that was a right angle triangle, that would be the end of the story. But this is also valid for non-right angle triangle, and then you have to do minus 2bc times cos A. Okay? And lastly, the area rule, as I told you, this is going to be very useful for us next year in geometry. Half times b times c times sine A, which is the angle in between. Okay. So now this exercise is a bit similar to exercise 3. Okay, we're in page 175, it's leading to exercise 5. And it's similar to exercise 4. We're basically using this, but instead of working with numbers, we're working with letters. So what they're asking us to prove is, okay, all right, let me introduce you to this triangle. We've got two triangles, ABC and BCD. ABC is a right angle triangle. Okay, and we see that here just about. Okay, that's at 90 degrees. Angles are given are alpha, beta, and gamma. Okay, gamma is a new letter. I think you can come across that, gamma. Okay, and the sides that we are given is x and y. So you can see there's not one number in this whole question. And what they want us to find is basically to show, to prove that y is equal to x sine gamma tan alpha over sine beta. Okay? You can see your faces, it's looking a little confusing. If there's one thing that is good about these kind of questions where we don't have numbers, that we don't need to use the calculator. So at least there's no chance of us making an error there. Okay? So let's think about it. I want to know y. That's what I want to know. Basically express y in terms of all the other quantities. Okay? Now, x is actually on the other triangle. Can you see that x is on this triangle? Okay? So what often I have to do is work with a side that is in common. Which side is in common for both of these triangles? BC. Yeah? Now, so let's look at this triangle. I'm going to give it another color. Okay? We'll draw this ABC. Okay? Now, the cool thing about ABC is that it's actually a 90 degrees triangle. So we don't even need to use all these sine rules. These sine, cosine will work for any triangle. If you have a 90 degrees triangle, we have much simpler relationship. And I'm sure you remember that. If I wrote y over BC, y over the line BC, what is that equal to? In terms of alpha. Something to do with alpha. Y over BC.
Sin alpha.
Is it sin?
Cos alpha.
Is it cos?
Tan.
It has to be tan, but why is it tan? Okay. What is the hypotenuse here? Which line is the hypotenuse?
AC.
AC is the hypotenuse. So y, if I'm looking at the angle alpha, y is the opposite. Opposite divided by BC. What is BC? Jason. Opposite divided by adjacent is tan, right? So it's tan alpha. Are you agreeing with me on that one? You happy with that? Yeah? Okay? That's before the sine. That has nothing to do with the sine rule. That we learned that in the first, maybe the second lesson in trig. Now, I want to find what y is, right? But I can do it very easily. What is y equal using that equation?
Y, sir?
Yeah. BC tan alpha. I just multiplied by BC. So that's what I've got so far. Okay? And actually, it's not looking too bad because what I need to prove, this is what I want to prove, right? I've got a tan alpha here. So I'm on the right direction. But do I have BC anywhere here? No, so I'm not finished. I need to find, basically, that's my motivation to find what BC is. Okay, I want to know what BC. If I find what BC is, then I'm going to substitute it here and then hopefully get that. You happy with that? Okay. Quiet fish. Okay, I'm going to highlight it here so we know what, once we know what BC is, we're going to just put it in here and hopefully get that. Okay, looking at BC, there's now more information I've got in a right triangle. So how would I find what is BC? Which triangle I look at? Only one. Okay? The blue triangle, BCD, yeah? Okay, okay. I want to find out what BC is. What could I do? I'm going to just pause it here and see if you guys have, maybe you can figure out by yourself. So you figured it out by yourself, a little bit of help, but we're going to use the sine rule. So let's see if you can do that. BC divided by what?
This gamma.
Not just gamma, but sine gamma, well done, okay? Will be equal to what?
Angle.
Which side do I have here? Okay, it's always a side divided by sine angle divided by equals side divided by...
Is it angle P?
BD. What is BD equal to?
X.
X. There's no point in me taking CD because I don't know what CD is and frankly I don't care. But I am given what BD is, so let's call it straight away X, okay? Because I know it is X. Divided by what? Sine, yeah, a bit louder.
VC.
X divided by sine.
CD.
Beta. X is opposite beta. So the sine will tell us X divided by sine beta. Okay? Alright, now we know how to do that, right? You guys are good at that. How do I find what BC is?
BC equals sin gamma X.
Okay, can I just put the X first? Because look, if I write sine gamma X, then it looks like maybe you think it's sine gamma time X. Like they're both inside. So I always like to put the thingy before the sign. So X sine gamma divided by
Sin beta.
sin beta. Okay? You see how it's much easier to me, in my opinion. I don't need the calculator here. So to me it's easier. Don't be afraid of it. Just leave this out your friends. Okay, why were we looking for BC? Remember, we always have to remember what we're actually trying to do.
We need to prove y equals
Yes. And remember, we said y is equal to BC times tan alpha, but I didn't know what BC. Now I know what BC is. What do I need to do?
substitute.
Plug it in there. Right? So let's write that down. We're almost there. Y is going to be equal. Okay, instead of BC, what should I write?
X sin
X
gamma
sine gamma divided by
sin beta.
sin beta time what?
Tank.
Tan, not tank. We're not driving tanks here.
Tan
Alpha. Tank alpha. Okay? Now, this is, I know some of you often are a little bit confused. Okay? What do I do with that tan alpha? If I had, let's say, 3/2 times 5, how do I write that? What is 3/2 times 5?
10/2.
Thank you. Okay, why is that? Because basically the 5 is on top. It's 5 divided by 1. Okay, so it's 3 times 5 divided by 2, which is 15/2. But I'm not going to do questions like that, guys. Sorry, we're not in grades 6, 7. Okay, so how are we gonna write that? The tan is on top. Is on top of the denominator. X sine gamma tan alpha divided by sine beta, which is what we want to prove. Okay, so EPA, we proved it. Okay, that's it. Done. Let's pause here and see what happens next. Okay, so the other examples that I've got here, and that's they use this term angle of elevation and depression. Okay? I hope you're not feeling too much depression right now. I'm not sure about some of you here feeling a little bit down. Okay? Right? Okay, let it rest, let it rest. I'll let it rest this time. Okay? Okay, so I know it's not easy, guys. It's not easy. Okay? But we mustn't give up. Not now. Okay? We do what we can, and then when we get eventually the marks at the end of the year, we decide what's the best route. Okay? Right, so we've got a tower. This is a tower. And we've got two observers. Observer A and observer B. The way they phrase it is a bit tricky, but that's another level of difficulty is to understand what I'm saying. Maybe I'll read what they said. From the top of the tower CD. By the way, we're in example 12 if you want to look at it.
So which page is this?
Page 176. 176, example 12. So there's no reason for you to copy it. From the top of tower CD. See, this is the tower. This is the tower. Shall I make like a decoration, right? There's a tower. Is that like a tower? Yeah? The angle of depression of an observer standing at A is alpha. What does that mean? If I'm standing here and I'm looking down at this person, there's a person here, that's observer A. Okay? I'm looking down, the angle of depression is alpha. So this is a line to horizon, okay, to the horizon, and I need to look below. That's called the angle of depression. Okay? Alpha. The angle of elevation of the top of a tower from an observer B is beta. So if I'm standing here I've got observer B, and I'm looking up towards the tower, that's the angle of elevation, looking up. Okay? We came across these terms last year. What they're asking us to do is, okay, the tower is X meter tall. Okay? So that's X in meters. Okay? And they're wanting us to prove that the distance between the two observers is X sine beta minus alpha sine beta. Okay? What is the distance between the two observers? This distance. So really, and they didn't write to you in the question, but you need to understand that what you need to prove is that AB, this length, is this crazy stuff. Okay? I'll pause here for question. Yes. Okay, so like we had before, we're going to work with two triangles here. Like we had in the last question, we had two triangles. Also here we have two triangles. Okay? The first triangle is that. Okay? And the second triangle that we're going to work with, I'm going to give it a black color, is going to be that one. Okay? Just bear with me, guys. Look at that. Do it best we can. Okay? So, what am I looking for? A. Yeah? A. Now, the problem is in the triangle, in the black triangle, I've got nothing. And you see, I've got nothing. Yeah. I've got no sides. I've got nothing, actually. So I need to start thinking, it would be nice to at least get a side in the black triangle. So let's look at the green triangle and see maybe the green triangle can give us a side of the black triangle. Which side will it give us? BC. That side. This side is joint for the black triangle and the green triangle. So let's try and find out BC. I don't know. Let's just try and do it. Okay? Okay. What about X and B? What is BC? In this is a right angle triangle. What is BC? What do you call that side?
A common side.
It's a common side, you're right. But just in the green triangle, it's the hypotenuse. So if I had X over BC, what will I get? X over BC. And you're obviously using beta here.
Beta. Sin beta.
Sin beta, you're right. Because we got opposite divided by hypotenuse. That means, okay, it's a little bit tricky. I want to find what BC is. I want to know what BC is, so then I'll be able to use it here.
BC.
Yeah, this is a little bit tricky. X over BC equals sine beta. I want to find what BC is equal in terms of sine beta and X. Right now he's at the bottom. That's no good. We never want these things to be at the bottom. How are we going to push it up the top?
X over sine beta.
X over BC.
You're right, but I want to see. So let's push the BC over to the other side, okay? So we're going to write X equal what? BC times
sine beta.
Okay. And now I will find out what BC is. Now it's easy for me to find BC. Jade, you already did straight away.
X over sine.
X over sine beta. Okay, dividing by sine beta. I'll just pause here to make sure you got that. Now we've got BC. You know, we've got BC, so we've got one thing over here. Now I want to find what AB is. So I've got one side, but I've got no angles. I can find our angles. Okay? What is A?
We don't know, sir. No,
Somebody said that.
alpha.
Alpha. Because these two sides are parallel, right?
Oh,
It doesn't tell you, but you need to understand the horizon is always parallel to the ground. So if this is alpha, this is going to be alpha as well. Okay, that's good. Now I can tell you that we can also calculate this angle. Now that's going to be a little bit trickier. I'm going to pause and see if anyone figure out by themselves.
Alpha, sir.
Okay, so you guys got it. Some of you got it, which is quite impressive. I'm gonna explain. So what you guys are telling me that if this is beta and these two lines are parallel, that is also beta. See, those two are the same. But now if this whole thing is beta and this whole thing is alpha, that's exactly the difference. This is going to be beta minus alpha. Okay? Interesting, eh? You can find it out in another way by figure out that this is 180 minus beta, but that's probably that's the way I would do it. Okay, let me write it a bit better. This thing is beta minus alpha. Now we're ready to use the sine rule to find what is AB. I want to know what AB, right? So AB, what does the sine rule tell me? AB divided by what? What should I divide it by?
Sine beta minus alpha.
Yeah, okay. Sine will tell you sine divided by sine the angle. So AB divided by sine beta minus alpha. And that's quite encouraging because I've got sine, that's what I need to prove, right? This is the thing I'm trying to prove. And I've got sine beta minus alpha, so I'm in the right direction. Okay? That is equal to what? I've got this side, guys. What is this side? BC. What is BC?
BC.
X over sine beta. Okay, that's BC. Okay, we found that it's BC. And according to the sine rule, it's going to be BC divided by what?
Alpha.
Sine alpha. Sine alpha. Okay? So maybe I'll write in two steps. Okay? The sine rule tells me that AB divided by the sine opposite is going to be equal to BC divided by the sine opposite, which is sine alpha. Okay, are you happy with that? Alright, don't have space. Let's rearrange that. I want to find what AB is, right? What is AB?
Sin beta minus alpha BC bracket.
Yes, but you know me, I always like to write BC first. So BC sine alpha times sine beta minus alpha. I like to write the sine alpha.
Where did we get BC from now?
BC, that's from when I'm looking at the sine rule at the black triangle. Okay, BC divided by sine alpha is equal to AB divided by sine beta minus alpha, right? But you're right, Simon, in a sense that that's not what I need to prove. I need to get rid of that BC. That's why we found the BC before. We found what it was. So now I'm going to plug that in here. Okay, so I'm going to finally get AB equal to, okay, this is going to be a bit tricky for you. X over sine beta instead of BC, and I'm going to time it by sine beta minus alpha divided by sine alpha. I'll just pause here and see if you guys are happy with what I wrote. Alright, we're moving on. We just multiply these things together. What are we getting? AB is equal to x sine beta minus alpha divided by sine beta, or let's rearrange. Instead of sine beta sine alpha, let's write sine alpha sine beta. We can change the order of multiplication. 3 times 2 is 2 times 3. And that's what I want to prove. Okay? Happy days.
Not happy days.
Okay? We're going to leave it there. Take care. Bye bye.